This is Pre-Calc 11, Chapter 1.3. We're going to look at geometric sequences. These are more interesting than arithmetic sequences. If we take an arithmetic sequence to an infinite term, it'll always go to plus or minus infinity. However, for a geometric sequence with a ratio between -1 and 1, these infinite series will go to 0 if we use limits. So we need to recognize geometric sequences. Here's an example. 1, 2, 3, 4. This is an arithmetic sequence. And this is an arithmetic sequence. 1, 2, 4, 8, 16. This will also go to infinity, but it is a geometric. And we can recognize this because we're multiplying each term by 2 to get the next term. Here, this one's also geometric. And this one will go to 0. And its multiplier is 1/2. So 8 times a half is 4, 4 times a half is 2, and so on and so on. This one will also go to 0. Its ratio is -1/3, and it's geometric. So we take -27 times -1/3, we get 9, times -1/3, we get 3, and so on. So as I've already mentioned, a geometric sequence will have a constant ratio between the terms, and that's a multiplier. If it doesn't, then it's not geometric. And as I've already gone over, the geometric sequences, these three, have ratios of 2, 1/2, and -1/3. And you need to note that the sequences never gets to 0, but just keeps getting closer. So if a sequence keeps getting closer to 0, or a finite value, then we say it's convergent. Otherwise, we say it's divergent. And a note here is that it doesn't have to go to infinity to be divergent. So we have a formula for general terms. The nth term is based off of T1 and r raised to the power of n minus 1. And it's very important to use brackets on calculators. On a calculator, you would have a bracket around r and brackets around n minus 1. Okay, so we just need to plug in n to get our nth term. So t of 4 equals 5, 3 over 2, and 4 minus 1 is 3. And this is 135 over 8. And it's okay to leave it as an improper fraction for this course. Now we need to find t of 3. And 3 minus 1 is 2. And it's necessary for you to leave this as an improper fraction rather than a decimal value. So you can always multiply the numerators and put your answer down, and multiply the denominators and put your answer down. Okay, in a backwards problem, you'll need to solve for r. And we just plug it into the formula. So T1 is 8, T6 is -1/4. We write down the general formula. Tn equals 8 times r to the power of n minus 1. And then we substitute. -1/4, 8, r, and n is 6, so this is 5. Divide both sides by 8, and we have -1/32 equals r to the 5th. Now we need to take the 5th root of both sides, so r equals -1/2. On your calculator, you would do bracket -1 divided by 32, bracket, and you would have this symbol, or you would have y to the x, and 1 divided by 5. Next example. Always write out your general formula until you're used to it. So Tn equals 9, r to the n minus 1. N is 7, substitute, 243 equals 9, r, 7 minus 1 is 6. 243 divided by 9, that's 27, equals r to the 6. Once you have r isolated by itself, we don't need the brackets here. You can just take the brackets out. Okay, and now we have r equals plus or minus the 6th root of 27. So r equals plus or minus square root of 3. One way to figure this out is we have 27 to the power of 1/6. This is equal to 3 to the power of 3 to the power of 1/6. So this is 3 to the 3/6, and that reduces to 3 to the power of 1/2, and that just means square root. Now, because we have an even power here, we have to do plus or minus. With an odd power here, we don't have to do plus or minus. If it's negative, your answer is negative. If it's positive, your answer is positive. Recall that if we have -3 squared, we get 9, and 3 squared also equals 9. That's why we need the plus or minus when the power is even. Next example. Again, we write Tn equals 5 r to the power of n minus 1. Substitute 80 equals 5 r to the power of n is 5, so that's 5 minus 1, we get 4. And here we have 16 is equal to r to the power of 4. So r equals plus or minus the 4th root of 16, and that equals plus or minus 2. So notice if n is odd, the answer has plus or minus. If n is even, then the answer is only positive or negative. Okay, here we're doing the 4th root, but n itself is odd. So n is odd, we have plus or minus. And back up here, n is even, and the answer can only be positive or negative. There is no plus or minus. Okay, and just a note, you'll be learning this next year. Geometric sequences are related to a special case of exponential functions. We have n element, the natural numbers, and we have no translations. And you'll learn about translations of functions later on. And geometric sequences have many real-life applications, including science, business, and music. So these are important functions. And that completes this lesson.